Hello everyone, and welcome to this video on the Python programming language and machine learning. So in this video, I'll attempt to predict the price of houses based on a few features like the number of bedrooms, the number of bathrooms, and the square footage. So right now I'm on Google's website. It's called colab.research.google.com, and I'm on it because it's really easy to get started programming in Python. So if you're going to code along with me, all you have to do is go to this website and then log in using your Google account and get started writing your Python code. And to get started, go ahead and click on File, click on New Notebook, where a new tab will open up for you, and then eventually a new cell will open up for you. And in this cell, I'm going to put in a description and comments. I'm just going to put a description about the program. So here I'm going to put this program attempts to predict the price of houses based on a few features. Okay, so next I'm going to go ahead and create a new cell by clicking this code button here in the top left, and in this cell I'm going to import the necessary libraries that I plan on using throughout this program. So I'm going to import pandas as PD, and then from Scikit-Learn.linear_model I'm going to import linear regression. Okay, next from sklearn.model_selection, I'm going to import train_test_split, and last but not least, from sklearn.metrics, I'm going to import mean_absolute_error. Okay, and then I'm going to run this cell by clicking this button here to the left, and this will let me know if I made any mistakes. So in the meantime, before we continue, if you like the videos on this channel, then be sure to click that subscribe and like button, and to be notified about videos from this channel, hit that bell notification. Also, you can get the code or the dataset or just support the channel on Patreon at patreon.com/computerscience, and I will leave a link for that in the description below. All right, so let's go ahead and continue. It looks like everything is good. We get this nice check mark. I'm going to create a new cell, and in this cell I'm going to load the data set. So I'm going to create a variable called data and set it equal to pd.read_csv, and then I need to input the name of the CSV file. So I have a CSV file called housing_data.csv, and I'm going to upload it here to Google. So in order to do that, I need to set data equal to pd.read_csv. All right, so in order to upload it to Google, I'm going to come over here to Files. I'm going to click this Upload button, and I'm just going to choose that housing_data.csv file. Okay. Next, I am going to show the data. So I'm just going to type data here, and I'm going to run this. And let me go ahead and just exit out of here. All right, so now we can see the data set. We can see these columns. One is called unnamed 0, which doesn't bring any value to us. The other one is called square foot, which tells us the square footage of the house. The other one is called bedrooms, which tells us the number of bedrooms. One column is called bathrooms, which tells us the number of bathrooms. And then age would be the age of the house. And then price is the current price of the house. So we have those 6 columns I just now talked about and 1,000 rows of data. All right, so let's go ahead and create a new cell now that we have seen the data or taken a quick look at some of the data, right, a sample of it. And in this column, I want to get the feature data, and I'm going to call it X. So I'm going to create a variable called X, and I'm going to set it equal to data, and then I'm going to give it the features that I want this model to be trained on. So the features will be the columns. So I want the square footage, I want the number of bedrooms, I want the number of bathrooms. Okay, so with those 3 columns, that gives us our feature data set, and then I want to get the target data set. So I'm going to call it Y, and it will contain the price of the house. So let's set Y equal to data and then put in the price column from our data set. So let's go ahead and run this cell. All right, so I'm going to create a new cell. And now I'm going to split the data into a training data set and a testing data set. All right, specifically I'm going to do 80% training and 20% testing. Okay, so I'm going to create a few variables. One will be called x_train. Another one will be called x_test. And then y_train and y_test. And I will set this equal to train_test_split. And I'm going to input the feature data set and the target data set. And then I'm going to input the test size, which will be 0.2, which is, of course, that 20%. Because again, I want 20% of the data to be the testing data. Okay, and then I'm going to set the random_state equal to 42. And the random state is the seed used by the random number generator. In general, a seed is used to create reproducible outputs. Okay, so let's go ahead and run this cell. Let's create a new one. And now I'm going to initialize the linear regression model. So that's easy enough. I'm going to create a variable called reg and set it equal to linear regression. Okay, and then I'm going to train the model on the training data set, and that's easy enough by using the fit method. So just type reg.fit, and fit is another name for train. And then I'm going to input x_train and y_train. Okay, and then I'm going to run this cell. All right, so now we've initialized our model and trained it. So let's go ahead and create a new cell. And here I'm going to get the predictions of the model. So I'm going to create a variable called y_pred. y_pred. And I'm going to set this equal to reg.predict. And I want to make these predictions on the test data. So let me make sure I'm spelling things properly. Get the predictions of the model. I'm going to put on the test data. So we're going to put in x_test here. And let's run this. Okay, so I'm going to create another cell. And now I'm going to print the predictions. So just type print and then put predictions : \n for a new line. And I'm going to put y_pred, which again is short for y predictions. I'm not sure if I said it was short for y predictions in the first place, but ypred is short for y predictions. And then I'm going to also print the actual values. So I'm just going to type print and then actual values : \n and then put y_test. So let's go ahead and run this. Okay, so now we can see our predictions here. And then we can see our actual values here. All right, so for the first house, our model predicted that the price was 1.51 million and the actual value was 1.51 million. And for the next house, our model predicted that the price of the house was 2.555 million, and we can see that the actual value was indeed 2.555 million. All right, and so on and so forth. So let's go ahead and create another cell. And in this cell, I'm going to calculate the mean absolute error, or MAE for short. Okay, and MAE is simply, as the name suggests, the mean of the absolute errors. So let's create a variable called MAE and set it equal to mean_absolute_error. And we're going to input y_test and y_pred. Okay, So the absolute error, or the mean absolute error, is the absolute value of the difference between the forecasted value and the actual value. And MAE tells us how big of an error we can expect from the forecast or prediction on average. So let's go ahead and run this, and let's create a new cell. And then I'm going to print the mean absolute error colon and then MAE. All right, so here we're just printing the MAE, and let's run this. And we can see the mean absolute error here is 7.473, and you get all the rest of these numbers here, times 10 to the negative 10, right? So that's extremely, extremely small. This is an extremely small absolute mean absolute error. All right, so that's basically the end of this video. The best score would have been a 0 for the mean absolute error. And please remember that this is just a simple model to showcase some Python and machine learning. So I hope you enjoyed it. Thanks for watching the video, and a special thanks to the Patreon supporters on patreon.com. Again, if you would like to become a supporter of this channel or get the code or data sets, I will leave a link to the Patreon page, which is patreon.com/computerscience, in the description below. Thanks for watching, and I hope you all have a fantastic day, and I'll see you all in the next video.